Welcome everybody to Robot Builders Night Virtual. It's a Dallas Robotics Programming Robotics Group for October 29th. As usual, we'll do a roundtable discussions. Everyone that wants to can spend a couple minutes telling what they're doing, working on, and then after that we can do ad hoc presentations or questions, stump the club. Just a reminder that the meetings are recorded, so if you don't want to appear on this video or be heard, mute your mic and turn off your camera. With that, we do have an event coming up next month in November on the 23rd. We'll be having a Dallas Personal Robotics Group Robo Columbus Plus event. The Dallas event will be held the 23rd, a Saturday. And as well, by default, we did not have our meeting last Saturday in Canada, our contest. So we'll be having a contest the same day in Canada, if the robot gods are willing.
So why didn't you have it?
Not ready.
We were not ready. And I wasn't ready and Tom wasn't ready, so there was no point in having a contest. Yeah. We would just, I'd spend a bunch of money getting there. Tom would go through a bunch of inconvenience and nobody would be happy anyway. So that's why we've postponed ours. We're going to try to give ourselves a little more time. I know I'm frantically reprogramming my robot, trying to get everything to work a little smoother. And I believe Tom is in the same process. We'll see if we can get it done. Up tonight, we had a couple people that have something to present, and I guess we'll kick off with Ray, who had a question about BNO 55 or a follow-up. Yep. Go ahead, Ray.
On the two outdoor platforms that I'm currently working with, I have it's not really a calibration routine. I do calibrate the BNO 055 on just after power up. And I do, it's like you go through pitch, yaw, and roll in basically just take it and rotate it 360 degrees in each of those directions. And there's, you can look for what the calibration state is. So there's one for system, there's one for the accelerometer, the gyro, and the magnetometer. And if you're, each will start out at 0 and go up to a 3. And 3 is, I guess, as calibrated as you can get. And I've done that before the contest. I do have the BNO maybe somewhere between 1.5 feet and 2 feet off the ground. On the one robot, it is directly above the motors because that's the kind of like the turning point or the center of the robot. On the one with 4-wheel drive, it's in the center of the platform. So I guess it's roughly the same. It's about the same distance from the motors. The motors on the 2-wheel drive robot are completely encased. There's no slits or slots for cooling or any of that kind of stuff. The wires come out of a very small hole with a grommet on it. So I think as far as shielding, that probably, I think, shields the BNO 055 the best. On a 4-wheel drive platform with Go Builder motors, those do have slots on them for, looks like to get air in it to cool it. There's a little fan, kind of centered on where the slot is. So I don't know if those will be noisier motors or not, but they are different. So far, it doesn't seem to have affected it. The BNO works pretty good on either platform. And the way I navigate, I was using Dave Anderson's equations, and I get the azimuth angle, and basically that's where I want to be pointing. And I use what the B&O says the platform is pointing to and make it point to the azimuth angle. So, and it seems like it's worked pretty good so far. And the accelerometer, the gyro, and the magnetometer are enabled. So I don't know if the distance, I do have it a pretty good distance off the ground. I don't know if that's what's making it work pretty good, but it seems like it works pretty good on at least 3 different platforms that I've tried, outdoor platforms. So
You have auto calibration enabled?
I'd have to look in the code.
I don't think you can turn that off on the B&O.
Yeah, you can.
You can?
Can you? Yeah, I don't think I didn't mess with it. I don't remember messing with it. So I think it's if it normally comes on, it's on.
If you saw the numbers go up to 3, that kind of implies that it's calibrated.
Yes. Yeah.
Well, you can trigger it explicitly too. So.
Oh, okay.
Well, yeah, I'm trying to do the, basically rotated in each of the 3 planes and, 360 degrees in each of the 3 planes. And that seems to do it. So
How do you rotate a whole robot? How do you tumble a whole robot?
I have
it off?
a small piece of tape that holds the connector onto the mast, and I pull the tape off.
So that's not a so I forget whether it's soft iron or hard iron, but what that means is that you're pulling it away from the magnetic fields on your robot, so it's technically not the best calibration that you might get, and so it might not apply once it's mounted back on the robot. Now it sounds like your mast is sufficiently high enough that it's probably not going to make a huge difference.
Mhm.
Yeah, the calibration, sometimes people have problems with the calibration because they do what you're doing and then they stick it back on the robot. And the magnetic fields are totally different there.
Yeah.
You also don't want to just physically move so if you're doing a drone or something like that, you have to basically do it with the motors turned the motors turned off.
Mhm.
But that's not necessarily the same as when they're running.
Yeah. Yeah.
I calibrate mine by driving it around in a circle first in 2 dimensions, and then I pick it up and rotate it vertically a couple of times.
Okay. So you don't do, let's see, what would that be? Roll. You just do pitch and yaw.
Mike, I have to say I'm not happy with my calibration yet, but that's what I'm doing, and it seems to come close. So,
If you're driving it around, you're only getting yaw.
right.
yeah,
pretty
X
much.
and Y axes. That's why I pick it up and rotate it vertically to get the Z axis.
Well, that's yaw.
Well,
X and Y is yaw.
It's both pitch and yaw.
You want to move all 3
Pitch
axes
and roll. Yeah.
through 360 degrees. Right?
You're only getting one if you're when you're driving it around on the ground.
Yeah.
Yaw.
But that is the
It's
most
yaw.
important.
I'm getting calibration on 2 axes. I'm rotating 2 axes, the X and the Y axes. They're both moving.
No,
got-
only your yaw is moving.
You're talking in terms of the output. I'm talking in terms of calibration of the sensors themselves.
Yeah, and that's right.
Which have offset and gain issues to deal with, right?
If otherwise you're only working in one plane, and that plane is the yaw plane.
Yeah, for purposes of compass measurements that are not tilt compensated. In order to get tilt compensation, I've got to calibrate the Z axis as well, which is why I pick it up and rotate.
Yeah, but it's actually you're thinking in terms of direction axes and not rotation axes. So when you tumble your robot, when you pick it up, you're actually doing 2 of the axes then. So it's
Okay.
right. your two rotation axes is in the Z direction directionally.
I rotate it around the roll axis and I rotate it around the pitch axis when I pick it up.
Okay.
Oh, you do. Okay.
Now, I don't know how well my calibration is working. I'm not happy with the results for tilt compensation. So I still have some work to do.
Right.
But your motors aren't running anymore at that point.
Not when I pick it up, no.
Usually I set it on I turn everything on and set it on the box and the motors start. And I do the calibration, and they do some weird things based on what happens during the calibration. But once I tape it back up there, it seems fine. So,
My experience is pretty limited with magnetometers on. I'm just doing IMU mode almost all the time, which you can get away with if you're using RTK.
So
The more I'm working with my compass, the less I'm liking it.
yeah, after last week's discussion, I went and took my B&O off the robot just to simplify things and put it on a particular spot on my desk. Then I used Google Maps to get a good idea of where north was and exactly which direction it was facing. And I think it was off by about 4 degrees. And then I took my phone, put it in the exact same spot, and it was about 4 degrees the other direction. And then I picked it up, moved it, both of them around, and they both moved, I think, like 2 degrees closer to the real heading. And then, I repeated this several times. I'm not a very good scientist, so I didn't record anything. But yeah, I see that, Tom. That's probably what I needed to find was an actual magnetic compass, but I didn't find one of those. Anyways, after doing this, I found that it was, I don't know, about plus or minus 5 degrees anytime I measured it on like sort of a bell curve. So that's about as good as you can expect, I think, from anything between my phone and the B&O.
Has anybody tried, I think it's called RVC mode in the B&O 085? Robot vacuum cleaner, RVC.
Don't have one.
Huh?
Don't
you
have
don't have
one.
one? Oh.
That's
Yeah,
what I'm using.
Oh, you are? Okay. I don't remember. Is there like some sort of auto calibration routine with that mode, RVC mode?
I honestly don't remember because I haven't touched my stuff in a while. Just don't remember if it was auto. I know it had the ability to for calibration.
Okay. Yeah.
And that RVC mode, I mean, one of the things that's different about it, it basically, if I remember that correctly, so it updates faster maybe, and it doesn't pay attention to the magnetometer. That was one of the things. It's really more just focused then on the gyro in it.
Okay.
Oh, and when I did this experiment, I did take out what do they call it? The magnetic declination. So that wasn't the issue there.
Okay.
Or deviation, whatever they call it, where your magnetic north isn't the same as north.
Yeah.
Mm-hmm.
Hey, Ray,
Yeah.
on your experiment, did you capture your starting values? Otherwise, did you calibrate it, get like a ballpark calibration, store it, and then restore it when you started it again? So you're starting fresh every time, right?
Yeah. Yep.
Okay. All right.
And it's this little display spits out with the system, the accelerometer, the magnetometer, and the gyro, what their state of calibration is. So if it, something happens, I can pretty much see it because it's updated.
Mm-hmm. So you get, for you, fully calibrated is 9, right?
Well, it's each one has the value of 3.
All right, so you get 9 when you get finished.
Yeah.
Okay. And
And I have noticed like occasionally it'll drop down to like a 2 on, it seems like the accelerometer for some reason will do that, but it still seems to work pretty good. So,
okay. Well, we know that it auto calibrates sometime in the first 2 minutes. So when you're sitting there, you're letting it go for longer than 2 minutes before you start really using it. Am I correct?
yeah, because
So you're using their auto calibrated values.
most likely the yeah, because I have to wait for what is that? The Neo M8P-2 to start blinking its lights, indicating that it's got enough satellites. And
Mm-hmm.
And I actually have to start the RTK. I'm just calling it the RTK box. It's got the another Neo M8P in it, and it's put in survey in mode. So, and then it starts transmitting RTCM3 data to the rover, but that takes like 5 minutes, at least to get to that point. So, so I have to do that first.
Is this similar to what you did last year? The reason why I'm saying is last year, I don't remember your robot wandering. It went in pretty straight lines to wherever it had to go. I mean, it didn't all of a sudden decide to take off for the woods. So I was just curious, what type of filtering are you doing on it? Are you doing any filtering?
No filtering.
Okay. Okay.
So I look at it every second. The GPS is updated. So I look and see what it is there, but it's closed loop on the angle. So as it's moving forward, it's looking at the compass, and it's trying to use the heading from the previous second to stay in that line, and and it it doesn't adjust too fast, but it's not like it'll do if it passes a point, it won't do a sharp 180. It does kind of a gradual
gotcha.
a bigger circle than the the turning radius of the robot.
Can't you bump it up to like 5 hertz or something like that?
I think I can, yeah, but it seems to work okay at 1 hertz. So it's not terribly fast. It doesn't go that far in a second, so.
Yeah, I think at 5 hertz though, you don't even need an IMU at all if you've got RTK.
Yeah,
I'd be watching the status pretty closely, but you could actually just use the heading that you get directly. You can get the what's it called? Something over ground. There's a message that gives you your directly from the U-Blocks device that gives you your heading of travel.
Heading of travel. Oh, I just thought it was one of the things let's see, what are they? UBX messages?
Yeah, it's one of those. One of those has, or actually a whole bunch of them have. It's so redundant. There's so many different types of things, but yeah. I think there's ROG, run over ground, or something like that. Or there's another one. It's direction of vehicle or something. I don't remember what they're called. They're all in the manual, but
yeah, I know more by their numbers. Like And these are the ones that Spark found.
There's a good one in the PVT message, the uBlocks PVT message.
Okay. Yeah, the ones are, and I don't know which ones of these are. I didn't look at what other names they had. 1077, 1087, 1005, and 1230.
But those are RTCMs, aren't they?
Yeah.
Yeah.
Oh,
no,
that's what I
but
thought you were talking about. The
no. The RTCMs just give you the corrections. I'm
okay.
talking about from the well, I'm talking about the F9P now. I don't have
Yeah.
direct experience with the 8 model, but on the F9P that you can get those uBlocks messages. So PVT is the position, velocity, time message, and one of the parameters in there gives you the robot's heading of travel, which is accurate if you can ask it for like it's sensitive to the amount of basically it's velocity, right? So it won't actually put out a heading if it's there. You can set a threshold to say I'm moving too slow, and it wouldn't mean anything. But you can if you've got an RTK fix, then just a reasonable walking speed will give you a good direction of travel. So in other words, the RTK engine is computing that based on the recent historical waypoints that you've traveled.
Mm-hmm.
So you don't even need an
Yeah, I want to say the PBT was new for the F9. I don't think the
Was it? Okay.
F8 had it, as far as I remember.
Okay.
Don't quote me on that, but that's what I remember.
I don't know the M8s, so yeah.
Yeah. Apparently there was quite a bit of a change between the 8 and the 9.
Okay.
All right, so Ray,
Yes.
I would like to see someone be successful with a magnetometer, but I just wanted to point out that when I was doing the SparkFun AVC, myself and some other competitors found that at least running on a paved asphalt parking lot, you could get several minutes with a magnetometer before the drift got bad enough to be a problem. I think it was somewhere around 1.5 degrees per minute for the BNO. And so, and really we were finishing the course in less than 2 minutes. So for that, it was an obvious choice what to use when you're magnetometer.
But you were running that without magnetometer.
Or yeah, I'm sorry. The gyros were doing 1.5 degrees per minute, and the magnetometers were like all over the board, plus or minus 5 degrees. You know, the downside of the gyros is they drift in one direction and get worse over time, where the magnetometers, at least you get errors in both directions usually. But yeah, if you're finishing in less than 2 minutes, then the gyros are the obvious choice.
If I remember Ray's robot, 2 minutes is a dream. He's about halfway to the first cone by 2 minutes.
Yeah, well,
but this year he's got super robots, so who knows?
Yeah, getting to the first cone in less than 30 seconds, you'd have to have a fast robot.
Yep. So I made use of Paul's conundrum there with the squishy cone and his bumpers that are too stiff. I actually got a cone and pressed it against my new bumper to see if it would squish it or whatever. And he must have some awfully stiff springs, or he's got a really soft, squishy cone that he tested with, because mine doesn't deform the cone that much at all. And so yeah, I'm not certain what's going on there. I was kind of surprised to see that.
So, hey, Ray, you say you made some new robot. I mean, new. Can you show us the bumper mods?
Yeah, I think I can. I'm going to try to use my phone as a camera. DPRG website.
Mm-hmm.
Come on. Ooh. Add account. May take a second. Okay. Oh,
So Doug, are those tennis balls going to be bright and new?
Ooh.
Probably, because I'll probably buy them, like the night before. So,
Have a dog to break them in.
no, but there's no guarantee. If I happen to find some that were somebody already had, I might not buy them. But I looked on Walmart, and there 3 of them are like $1.50, so they'll probably be pretty bright.
Another way to identify the cone.
Well, I mentioned that in Discord. That if you're using a blob detector, this is really could be a way to capture false positives. But I don't know how big a tennis ball will show up in your field of view. It might be too small.
And you could get orange tennis balls too. Just
Oh,
the
yeah, I said I'd be willing to pay
That'd
them.
be evil.
Yeah. Yeah.
Am I going to have to retrain my robot now to detect the tennis ball on top of the cone?
I don't think so. I'm not. But we'll see. I mean, you got cones, don't you, Pat?
I do. We do.
Throw a tennis ball on.
Dude,
Are you a tennis
nice,
ball?
Ray.
Ray, you're not coming
Ray,
across.
you're muted on both your cameras.
Ray, you're muted.
You need to unmute the phone if you want that to show up on the recording.
okay. Can you hear me now?
Yes.
I hear you.
Okay, so this is the new bumper. I have like hinge points here and here, so I really wanted to,
I don't see it.
Oh,
Oh,
okay.
here it is. Wait a minute, I got it.
Okay, so that's one side. I have the wheel off on this side because I had to put some additional screws in, so I can push one side or the other, and the other side doesn't get tripped. Or if I hit a cone, then both of them, either one will trip. Or both.
Is there a second? Yeah. Okay. So there's a second. The screw down the middle. It's got 2 supports in the back.
Well, there's nothing in the middle. There's just one on. There's one on this side and one on this side.
No. Okay. So I mean the side supports.
There's a horizontally. It's it's prevented from going vertically.
Yeah.
Yeah. It can't be pushed up.
Because that's pretty. That is a pretty weak spring. I mean, it's a nice selection. I'm just saying.
Yeah. Anyway, that
Probably
seems
different from what Paul was doing.
Does it jam if you lift up and push in at the same time?
No, it's I 3D printed 2 kind of black plastic U-shaped pieces. And whoops, camera just flipped around.
All those mounts are entirely plastic.
Say that again?
Those mounts, those U-shaped mounts are plastic?
Yeah, 3D. I just 3D printed them. So this is there's a little, it's just a piece of brass that's got a set screw in it, and this switch is actually beneath it. So the piece of brass actually pushes down on the blade of the switch.
Clever. Nice.
Nice.
Yeah.
Anyway,
Yeah, that's really nice.
so the previous one, where'd the camera go? Okay. I actually 3D printed these that went around the wheels or into the center of the wheel, because the edges were catching grass and but I don't think I'm going to have that issue with this one, because these are curved out a little bit, and I'm gonna curve them out a little bit more, just sand it down, and it comes to like a 1/4 inch shy of the outside edge of the tire. So I'm hoping that I don't get snagged in weeds again.
Is that 3D printed part, the bar?
No, that's actually from, bought a tray from IKEA, and that's actually what's underneath all the electronics here.
Yep.
This gray tray.
Yeah.
And these were the edges of the tray. I just cut them off with a bandsaw and kind of, rejoined them in the middle.
Gotcha.
And they have the edge of the tray, so they're stiff, but it's not gonna,
Yeah. So are they L-shaped or U-shaped, or are they square?
Yeah, they're more like
Oh, okay. So they're L-shaped.
kind of L-shaped.
Yeah, gotcha.
Ray,
Not quite.
Ray, how far
Yeah.
above the ground is your bumper bar?
If I had to measure it, okay, that was 4 inches. Okay, so it's 4 inches to that point. About 7 inches.
Is that a design criteria or just happenstance?
Well, if I get into taller grass, I didn't want to have the bumper, triggering off on that. So, that will help. So yeah, I guess you could say it was by design.
Okay.
And the switch doesn't trip until it's almost completely depressed on either side. So even if it does hit something that, is tall, not unless it's probably too hard for the robot to go over, it will trip.
Okay. Maybe when you're done, the rest of the group can comment on their experience with bumper heights.
Yeah, so I found putting it below the center of gravity of the cone was somewhat important. That way you tended to push the cone and not knock it over.
Yeah.
And I would say you want it above the center line of the tire, just to give you.
So that's what this is. It's just, I don't know if you can see the tire from there, but
Yeah, I can see you're up. Yeah, you're seeing above the center line. I would say that's the other criteria. So if you have small wheels, you got to be up higher. Do you know what I'm saying? But I don't think you ever want to get where your bumper is lower than the center of your wheel, or your axle, I should say.
Why is that, Doug?
Well, then your tire is going to be a little bit inhibited by the bumper, I believe, because when you climb anything, you can climb about to your to your clearance angle. Anything above that's not going to come into play. But if you're down and you try to climb a curve, your bumper is going to engage before you've used the climbing ability of your wheel.
Yeah, that's a good point.
anyway, so hopefully it's a good design. I can run it into some weeds and see what happens. Hopefully there's not some.
It looks really good, Ray. I mean, I like it. I especially like the long throw before engagement. That's
Yeah.
really nice.
Yep. Yeah, this did take the Ackley rule of three. I printed one, just to say, okay, well, this is approximately what I think I need. It wasn't full length, but it had all the components to mount the rod and the switch. And the second one I screwed up, and instead of putting the little block that holds the switch at
The
20
little
centimeters
shelf,
down.
you mean? The
Huh?
shelf? You mean the switch shelf?
Yeah. So the switch, there's two screws that go into it,
Yeah.
and you can see the holes there, I guess, maybe not. Anyway, so for some reason on the second iteration, I decided that should have been at like 10 centimeters down from the edge. And actually it was supposed to be 20 centimeters down from the edge. So the third was the charm as predicted by Dave's rule. So
Yeah.
Do you have any idea what kind of plastic those IKEA trays are?
I don't. I don't know.
Do they look like Bakelite? I'm just curious. A lot of trays are made out of Bakelite.
Threw out the label already. I don't know.
Okay.
And it doesn't say.
Yeah, what about the recycle? Do they have a recycle deal on it? Does that?
Nope.
Okay.
Huh. Yeah.
So it looks more like the tray itself must look more like a cake pan instead of like a sloped edged tray.
Well, the edges they're kind of sloped. I mean,
Okay.
Yeah.
it's not, not like rectangular.
Okay.
I don't know if you can see it that well, but
Hmm.
they're definitely, larger than the base.
Yeah. Okay.
And so I just cut out the bottom of it for, to hold all the electronics, and then these
Yeah.
pieces were left over. So
Yeah. Yeah, I used to go to dollar stores sometimes and go over to their kitchen section, and you could find things over there where like their big 10 plates, 10 things, just things that you couldn't get that piece of metal for $1. Do you know what I'm saying?
mm-hmm.
It's easier to buy the tray and cut it out than try to buy the metal. So
By plastic electronics project enclosures there.
yeah. Have you tried to bend it with heat? I'm just curious.
Not with heat. I know it. I tried to cut it with some tin snips.
Yeah.
And it shatters. It doesn't cut well at all.
Gotcha.
So fairly hard plastic.
Mm-hmm.
So
That's cool.
yeah.
Well,
Yeah, I couldn't believe that. I looked at the price of Lexan at Lowe's, and it was like, I was flabbergasted. It's like, oh my God, is there a world shortage of Lexan or something? I'm going to look it up again here.
Great. Thank you for your bumper presentation. I've just sketched out the one I have to build.
Yeah. That's nice.
Really nice.
Well, thank
Just
you.
for grins, since we've all talked about your bumper, are the shafts 3mm or are they smaller?
I have my handy set of calipers here. Hold on a second. Cabinet sheet. Yeah, okay, so here's a 12 by 24 polycarbonate sheet, $22.
Mm-hmm.
It's amazing. Okay, let me look at, I think they're 3mm. Actually, they're 3.98.
Mm-hmm. Wow. Okay. Nice.
Yep. Anyway, so hopefully I won't find another Paul gotcha or something. Yeah.
Yeah. Well, it all, I'm sure. I mean, since, you know, I know that Pat and, let's see, I can't remember Pat and Tom had to call their competition date, and they moved it back. I'm just wondering, what was the thing that you just didn't have time to get the final bid, or what's the big, if you said, what's your big remaining problem? What is it?
Go ahead, Pat.
Evil compass.
The evil compass. Okay.
And I have one of those as well.
Okay. All right.
Oh, I
Curiously
ran
enough,
into,
we have the same compass.
yeah, I ran into a big issue. As soon as I turn the motors on, my compass just goes wild. So even though it was calibrated with the motors and everything, when the motors start to run, it just goes nuts, and to the point that it's unusable.
If you just like temporarily powered it up with a battery that you held above it, would that solve the issue? I mean, is the problem in your power line, do you think, or do you think it's actually a radio? You know,
I'm not sure. So when it's just sitting there with everything running, it's running very, very stable.
okay.
As soon as I power up my motors, it just goes wild, like plus 90 or minus 90 degrees.
Is the
And-
motor taking power from the same? The motor's going straight from the batteries, right?
Motor is straight from the batteries, but I've got a 5-volt buck converter off of the battery as well.
Yeah, but is that
And that's
feeding?
powering up.
Is that feeding your motor control board?
It
No.
feeds the motor control board the 5 volts on the motor control board.
Yeah.
Are you
So
running
that's
your
being
wires
fed.
through a choke?
No.
That'd be interesting. You don't have an oscilloscope, right, Pat?
No. Santa Claus is bringing me one though.
Good.
Did you ever get one of those little logic analyzers?
I do have a logic analyzer.
For this problem, you could put that on your power supply. Okay, so between power supply and ground, and then if it got tripped and shows you a bunch of spikes, then that would say, this is probably not the way it should be. And you could compare it with the motors off and with the motors on to see if it got worse.
Yeah. So when I was running it with the remote control,
yeah,
my motors were very steady, and the robot's able to drive in a straight line or follow commands. It's when it's in autonomous mode and the compass is being affected, it was just screwing up everything. Which I don't know, if it was just general noise in the system, you would think that a lot of stuff would be screwed up besides just the compass.
What about a Muse shield? Have you a Mu metal shield?
I was just thinking about that. Yeah. Can you shield your motors with like a piece of thin steel?
Well, my motors are sort of below a steel plate on my frame. So if you can see down in here is my motors, motors, front, back, the other side's the same thing. And I do have a steel plate right here. Okay, between there and then the next level up is the electronics.
Did you put the capacitors on the motor?
Yes, I did.
Okay, and that didn't do diddly, huh?
No, I thought it did when I first fired it up. I thought, oh, maybe this is going to work. And about a second and a half into it, it was just all over the place. So two of the motors with the encoders have 2 capacitors on the encoder board, and they're tied to the motor terminals. So there's missing a 3rd capacitor on those boards. It's not there, and it's not easy to install.
Okay.
And then the other two motors that I have, I put 3 capacitors on each of those motors.
Hmm.
So
Can
it took
you
me
use-
about the,
Pat, can you like not run, just run one motor and see if it goes nuts, and run the next motor and see if it goes nuts? Or see, like front rotors, they go, you know what I'm trying to say? Try different.
yeah, so the motors are in parallel, front, left and right motors are in parallel.
Yeah.
But I could run just the right motors or just the left motors if I
Or you
change
can
my
just
computer.
power up one, just disconnect it temporarily.
Well, yeah, that connection is buried deep.
Oh, yeah.
Kind of wondered what do you think the frequency response of the average multimeter is? Is it like 10 kilohertz maybe at max, or?
You mean,
Um,
I think that depends on what type of, if you're talking about a digital meter, then I guess it probably depends on how expensive a meter you got.
Yeah,
Analog
I kind
meter,
of wondered if stick it on the most sensitive AC scale and look at your DC rails and see if see if it read anything,
Yeah.
maybe in the millivolt range or something.
because Pat, in your staff, your mass is like humongous. It's way up in the air. Isn't it?
Oh, yeah, I want to cut 6 inches off of it. I think it's way too tall.
Yeah.
To the point of, as you tilt, 15 degrees one way, well, it wants to maybe flop over because it's so tall.
And your magnetometer has a ground plane, right?
My GPS has a ground plane. My magnetometer does not have a ground plane.
Okay. Well, sometimes the compass is mounted with the GPS. I didn't know what your combo was. So you got an independent compass.
You want to be
Yeah,
careful
so
that you don't put anything near the compass that will distort the Earth's magnetic field.
Yeah.
yeah. So
Yeah,
I've got
an aluminum ground plate won't do that.
okay. There's my compass, and it's on a wooden mast halfway up my mast, and there's my GPS at the top.
Yeah, I gotcha. Oh, what's the black flashing green light mean?
You're talking about this guy up here?
Yeah. It was flashing earlier.
It does that occasionally. I got to figure out why.
In indoor reception of satellites. That's what mine does.
That tells me the number of satellites I'm connected to.
Oh, okay.
Okay. I
So
gotcha.
basically, there's a little Adafruit trinket module in there, and it gets the serial message from the compass, and it sends it out on the USB. But it also, for troubleshooting, I use the little RGB LED on there to say, hey, how many satellites are connected?
Is it an RGB or a NeoPixel?
It's a NeoPixel.
Okay, now I'll tell you this. On my experiences, NeoPixels are extremely the communication across the 2812 or whatever it is really really noisy. You might, as an exercise, is turn off all the NeoPixels on your board. I know you have a ring. Don't you have a ring?
Yeah, but it's easy to turn that off. I can just disable the routine in the program, and then
Okay.
I'm not sending out a clock pulse, so everything will be off.
Okay, so you might try that and see, because like I say, I ran into an issue. I was trying to run a little strip, like just the different LEDs would tell me different messages, blah, blah, blah. Which, by the way, it got so complicated I couldn't figure it out in actual life. But well, not the code. I mean, I'm sitting there looking at the robot, and the third light comes on and it's green. What does that mean? That was what I couldn't handle. It was too many messages and too few of LEDs. But anyway, they were very noisy, and I did have problems with them. So you might try that. Just turn off all of that and just see what happens.
You've got a good point. They run at very high frequency and moderately high current too, don't they?
Well, I'm just saying that, yeah, they could be pumping some current.
Well, I'm just running 1 or 2 LEDs at a time.
Yeah.
All right.
So
Well,
I don't light it. There's 32 of them, but I only light 1 or 2.
Yeah.
But yeah, I never thought of that because
You're actually,
You do-
chaining them down all 32s though. It's, it's a serial loop.
Yeah.
so the other thing is I do my update once every 150 milliseconds.
What up?
What update?
So for my LEDs, I don't constantly write to my LEDs and say
Yeah, yeah.
show it. I just do it once, so it sends the signal out, programs it to, hey, turn this one off, turn that one on, and you do the show LED routine.
Yeah.
And I believe it turns everything off after that communication.
Mm-hmm. Well,
So if I don't call it every scan, I don't believe I'm not writing data to it every scan.
That's a good point. Yeah.
but you might, like I say, I definitely would try, because I have run into issues with those NeoPixels.
It's easy enough to turn the whole thing off and just disable the NeoPixel routine and just run it the way it is.
Yeah, well, just see what happens,
Yeah.
If you're all of a sudden your compass starts working, and to a certain extent, I don't think that's it. I'll tell you why, because you said unless you turned them off when you were running it without the motors. So it's the motors. So far, it's whenever the motors kick on, and so the NeoPixels have been running all the time, and we're getting good numbers, right?
Definitely. I'm getting
Or maybe
good
not.
solid compass readings, and as soon as my motors run, I'm
Yeah.
done.
Wait, I thought you said that it was working fine when you're driving them in teleop mode.
No, it's not. The compass isn't working fine. The direction of the motors and everything else is rock solid. Like if I say go straight, it
sure.
goes straight. If I
Okay.
say turn left, it turns left. So it's not like I'm getting intermittent communication to my motor routine that's causing a problem there. So to me, it's something based on the data coming back from the compass.
Okay.
So right now, I've rewritten the program to use odometry. And if I happen to be stopped after so many seconds, update the theta value of the robot, my pose on the robot with the compass value.
Hmm.
So
It's a
just
good
as a
workaround.
correction.
So if you run it, okay, so let's say you're not running your motors and you got good readings, and then you kick on your motors and then you kick your motors off. Do you start getting good readings again?
Yeah, after a settle down period, let's say, I do start getting good readings again.
So what you might want to do is just there's two possible, one way is you run them, you get your good readings, maybe you filter it a few times to make sure, okay, yeah, looks like this solid heading. Then you say, turning you guys off, this is the direction we're going to go. Gyro, you're in the right, otherwise this is the direction you're pointed in and you need to go to here. So now you let your gyro do some navigation, and then depending on how long you feel comfortable with it, you stop and get a new reading off of your but you should be also getting readings off of your GPS too. So like if you're coming down,
I don't know if I have. I've never actually had it go far enough in a direction to say, hey, here's the direction you've traveled.
oh, okay.
Because
Well, there's two ways. There is a value in the GPS messages, but there's also, you can say, okay, I was here in X and Y. This is where it said I was. I moved to this new location, and it said the X and Y tells me I'm here. So that line is going to give me a direction. I got 2 points.
Yeah.
I have the directional line, so you could calculate that. Otherwise, just keep Last time I looked, I was here. The next time says I'm here. The big problem you have to worry about that is if the GPS suddenly decides that you're 20 yards over the other direction. But at least when you're getting off started, that would be good.
Yeah,
Yeah.
that may be another way to do it as well, is to keep, I've got my target value and I've got my current GPS value.
Mhm.
But if I compare it to my last GPS value, it could give me, if it's farther than so many centimeters, it could give me a decent direction between the two.
Yeah. But it could also say, well, okay, I moved from this position to this position. So I moved this distance and I also have this direction,
Yeah.
Well,
yeah. So after, 3 meters or something, I could get an idea that, hey, you've traveled 3 meters from here's your from point to your last point or to the current point, and that's the direction you're traveling.
mm-hmm. How's the IMU doing? Is it, even when your motors are on, is it okay?
I'm not using an IMU.
Not using IMU.
Not using one.
You don't have a gyro at all?
Nope.
Okay.
Don't need one. Purely theoretical.
Okay. Are you using
Doug's jaw just dropped.
well, I was just wondering if he was using odometry to get the value.
I am using odometry.
Okay, so you're getting an angle from odometry.
I am also thinking of adding a gyro into that odometry.
Okay, well, I was trying to think about, the shortest path for you, because you got your robot all built, you're ready to rock. What could you do that's the minimal change that would?
Yeah, and that's where I'm thinking that a gyro would help me, because as I'm rolling over the uneven ground, the robot is pitching and turning and doing a bunch of stuff. So the gyro would definitely help with trying to keep that straight.
Yeah.
And possibly help to maintain an angle.
Mm-hmm. Okay.
I'm kind of curious. How do is your compass connected to the Adafruit board with the NeoPixel, and does it get its power from the Adafruit board or from somewhere else?
It gets its power from the compass gets its power from the USB on the trinket.
Okay. Oh, all right. Do you need that USB for are you using it to communicate something?
I'm using it to communicate a message back to the Raspberry Pi.
Oh, the Raspberry Pi, darn. I was going to say you could get like one of these little battery packs and plug in that USB cable and see if your compass readings are look better, but you're not going to be able to read them without the USB. So
No, I wouldn't be able to. I'd have to redesign everything.
yeah.
You'd have to cut a wire.
Yep.
Basically, all of my sensors are going back to my Raspberry Pi.
Mm-hmm. So you're both using the same compass, right?
Yeah, we are.
Okay.
Mine's wired differently than his, but
okay.
Mine's wired directly into my ESP32.
Oh, it is. Okay.
And it sits on I2C.
Okay. Are you using the ESP32 3.3 volts to power it?
No, I'm using the 5 volt. I have an expansion board that the ESP32 sits in, and the expansion board has a 5 volt regulator.
Oh, okay. And
most of my peripherals are 5 volts.
Okay. But the I2C it comes from the ESP32, right?
Correct.
Okay. There's not an issue with 5 volt outputs and 3.3 volt inputs, is there?
I use a level shifter.
Oh, you do? Okay. Well,
In my case, it's a trinket and it's 3.3 volts.
Oh,
So
okay.
my I2C is already 3.3 volts.
Darn, there are no simple answers here.
So, and I did move my, I did shorten my USB cable, and I moved, I basically moved it up closer to try to the compass to
Mhm.
try to say, okay, well, let's shorten the I2C cables and see what happens. And it was no change.
Yeah, man. Um, is there something on the web saying that that's the most, power supply sensitive compass out there or something? Or have other people complained about it or?
Don't know. It's
Okay.
all I know is from the last meeting, they said, I think it was Kareem said, compasses are evil. And I agree with them.
You second the motion.
I'm
If
thinking of
you
taking
can-
the compass
if you
to the
can
Catholic
keep them-
Church.
If you can keep them level, they seem to work just fine. I've had good experience with others as long as they were kept level. But as soon as I started to add complexity, I get into a mess.
Hmm.
Mine is perfectly level. And as soon as I turn the motors on, it's just a mess.
They should all be banished to purgatory, if not hell.
Yeah.
I
We
agree,
shall
Kareem.
get there eventually. So there must be a solution.
I'm frantically working on it. I'm considering a bunch of stuff. I do get into one issue as well once in a while, and I'm removing my communication backbone. The mosquito broker is leaving. It is going to be into one giant program.
Mhm. Yeah.
That was tonight's thing. So anyways, I wanted to apologize to everybody about last Saturday for not being able to run our contest. But it would have been pretty boring to show you an empty field with no robot.
Mine will run around under remote control, and that was all it would do. And that was only after I replaced my failed H-bridge. My H-bridge ran for weeks and finally failed.
Yes. Yeah.
Yeah, I have a much bigger one on there now.
Well, I'll be quite honest. All of us want to see you run in the snow. You saw the picture that we put up for the meeting, right?
I was impressed. I thought it was great.
That's what we want to see. So we want to see you going across the glacier.
That's what that's for. Is to go across the glacier.
So
Hey, I thought everybody in Canada had a snowblower. You can just snowblow the whole park, and clear it off.
I actually don't have one, but all my neighbors do, so I'm all set.
There you go. There you go.
Oh, I saw an ad
There's this-
today for a robotic snowblower. It was impressive looking, but even for Connecticut level snow, I think it's gonna be a little bit underpowered and too lightweight. So, but it was something I could use. But
There are
And I know mine has 220 pounds of torque behind it.
yeah.
There are two of them.
Having to push and pull it all over.
There are two of those that I know of in the Ottawa group. One is a snowblower and one is a plow.
So
Yeah, the Ottawa group had a write-up of it a couple of years ago, I think I read. It was interesting. I think they were using RTK GPS as well on it.
Christy, the unit that you were looking at, did it have like several attachments you could stick on it? Like
it did have several attachments. It was like yellow and black color scheme. Yorbo, I think, is the brand.
okay.
I mean,
Yeah, seeing that they show it like doing sidewalks, city sidewalks kind of thing.
no, it was this ad was showing it doing a large driveway.
Oh, okay. Maybe it's different then.
The city of Ottawa owns one now that they just bought for something like $50,000, a robotic snowblower, because every year they try to set up this enormous kilometers long skating rink on the Rideau Canal that runs through downtown Ottawa when it freezes. The problem is at the beginning of the season, it's a bit dangerous. So they decided that rather than have people go out there, they would send this robot snowplow out there to clean up the ice. So they bought one.
yeah. But I'm sure there's a bean counter somewhere thinking, person falling through the ice, my $50,000 robot feeling thing. I think I'll send out that human.
How many $50,000 robots do you have to put through the ice before you?
Robots don't have legal counsel as good as humans have.
Yeah, that's true. But
Anyway, so I'm having the similar analogous issues with my compass. I had worked hard to try and get tilt compensation working. It doesn't. The math isn't trivial, but the physics are straightforward. But somehow the math won't work for me. And I made so many changes to the software implementation. Then my calibration seemed to screw up, probably because I messed with the code too much. And after spending another day trying to figure out what's wrong, I said, I have to stop working on this for a few days or it's all going in the garbage.
yeah.
So
Well,
I have moved on to my sensors and back to my GPS stuff a little bit. I'm happy to say that I can get reliable GPS measurements within a couple of meters, not only of each other, but of the documented reference monument point that's in this area. So they're very, very accurate. A couple of meters accurate anyway, across 3 devices and the benchmark, and Google even agrees with the monument. So I'm pretty happy with that. I think there's hope there for GPS navigation.
Yeah.
It's good news. My 3 sensors are working well. I've started to calibrate them. They needed calibration for distance. 2 of them need filtering. So today I've been working on choosing a filter to use with them because they're noisy. So I'll probably use an exponential smoothing filter. It looks like it'll produce good results. What else have I-
Do you really need to mess with tilt compensation? I mean, your robots, I thought it was more for drones looking at, tilting side to side if it flew or something. Or
Yeah, the thing is that without a camera, I'm fairly dependent upon GPS and a compass to navigate. I have no odometry that's useful for that purpose. And I have no camera. And I'm just trying to get my non-contact distance sensors working now so I have some mechanism for avoiding bumping into things. But I still need some way to kind of go on the straight and narrow. And the problem with compasses, with digital compasses, is as soon as they begin to tilt, you get dramatic errors in the compass reading, like really dramatic. That's well documented. So roll and pitch will screw them up big time, even a little bit of roll and pitch. A 10 or 15 or 20 degree compass error is a lot when you're trying to navigate up this 100-meter long path with obstacles on both sides of it.
Yep.
Yeah, but that's assuming that you're out of tilt for so much of a distance. If the cone was uphill and 30 feet away, well, then it may be an issue that you're going in the wrong direction.
You haven't walked the field yet, Pat.
No, I haven't walked the field yet. I know what it's like back here behind my house, but I'm sure the grass is shorter here as well.
Yeah.
How steep are the slopes?
Well, you've seen the pictures I showed, eh?
Well, you can't get a sense of steepness.
Yeah, you can't see the steepness from there.
The issue is less a question of long run steepness and more a question of short run steepness. Those are the things that will throw the compass off. And if you're not careful what compass readings you're using and how you've filtered them, then you could end up making fatal corrections in the direction you're going in before you can recover.
You just need a 30-foot long robot. It'll smooth all of that.
I'm thinking it needs to drag an anchor behind it to keep it going in the right direction, like a drogue chute.
I believe there is a size limit in the regulations.
yeah.
Something tells me it's 46 inches.
And I thought I should get around to doing a bumper, but thanks to Ray, I now have a really nice looking design. Ray, thank you.
There you go.
Easy to build. What else? I did calibration of range on my 3 sensors. I have a one-dimensional laser. I have a sharp IR and an ultrasonic. The ultrasonic works the best of them all. I'm really impressed with it, interestingly enough. The other 2 are sensitive to surface and color, of course. So I've been testing with a standard white target and with an old piece of wood and with an orange cone just to see what the differences are. It's quite interesting. So 2 of them needed calibration.
I will tell you this, though, Tom, you have to be careful with ultrasonic. they're real sensitive to wind noise and stuff.
Okay.
Okay, I'm just saying.
I admit I'm only doing the testing here on my workbench so far.
Yeah. Well, you know, if you have one of those expensive ultrasonics like Kareem
Nope.
and
Dave Anderson.
Dave Anderson, you know, one's from the old Polaroid cameras. That's different. But if you're using just an inexpensive $3 or $1.50 ultrasonic, most you'll find that they can. I mean, you might do okay, but I wouldn't expect very far distance. You know what I'm saying? Before you get into trouble.
So much for that blizzard.
Yeah, yeah. I'm just saying.
Well, I'll be happy if I can get out a couple of
They
meters.
can't take much snow weight either.
Yeah. I'm happy if I can get out a couple of meters. Well, that's a good point. I don't know what this stuff will look like when it's attempting to detect things covered in snow.
Yeah, yeah. Well, I think that's probably worked for your advantage. Orange cones should really show up in a snowfield.
I did come across an old friend of mine who does software development for a living, who wants to get into this embedded computing hobby field.
Okay.
So I'm trying to convince him to build a camera system for me. We'll see if he does.
That would be good.
He's ready to retire, so he needs a hobby.
Okay. All right. Well, yeah.
Ted, did you have any? You were next after Ray on the list before we grabbed everything. Did you have anything else to add to your comments?
I don't even see Ray.
Oh,
No, I'm here.
Ray's there, but maybe
You-
Ted dropped off.
Oh, yeah, I don't see him.
That is gone.
Okay, we missed him. So
Mm.
after that, I think I had John.
John, you got stuff?
John,
Yeah, I can show
Huh?
something I found.
he was digging up some stuff.
Yep, and I think I found something. So let me present
A new
now.
compass module that works with motors.
No, unfortunately not. Sorry about that. But what I did find was okay. I actually don't want. I want to share a tab. Yeah, okay, that'll work. So what I found though was a camera for Halloween. So if somebody wants to build something spooky and scare, here's this.
Mm.
So
Okay, so this is the first application that I've seen for the new
yeah, I was going to say
yeah,
for the
right.
camera.
Sony AI, I should say. So, what they got going?
Yeah, so they show this and then they talk about a new camera, seemingly.
Mm-hmm.
Yeah, so the Sony IMS 500. And then they sort of walk through about how to set it up and the software and that. Unfortunately, I don't know that much about the cameras, so Ray would probably have a better idea on this all.
First I've heard of it, so you know more than I do at this point, John. So.
Well,
I've
anyway,
never seen that Python application either. Monkers or whatever it was.
okay.
MX, I think I don't know if it was above there or below there. It was a Python install.
Okay.
There it is at the bottom. Right there. Python 3 Monkers.
Don't know. Somebody's fork of Python 3, maybe?
No, I think that-
Python 3 OpenCV and Python 3 Monkers.
Yeah, I
Never
don't know
heard of
about OpenCV. I think that's just the OpenCV package.
Yeah, that's just the OpenCV package, but it's the second package.
And I think that second one might have to do with the Sony camera.
I'm thinking that probably, yeah. That would, at least to me, made sense.
But anyway, so let's see what they did with it.
So they have that,
Okay, so they got it stuck on a wall.
and then there's more software. So this is the strip that they use to. Okay. And then they use this network model.
Mhm.
And then mainly to see if you find a person in it. And then there's sort of the relay battery set up. And there's, yeah, it sees the person, then moves this. And that's what they have, and they don't have a video. I don't think.
Hmm.
You go back, did they actually show that as a person, John? Slide
Yeah,
back down. How is the object labeled?
there we are. Yeah.
What does it say there? Is it just a box around it, or does it actually say person?
I think it said person, if I remember. Somewhere in this, it says something about.
It says parent board on a curb.
They're sending a message.
I'm trying to figure out if this guy's using.
If a person is detected.
Okay, so it's a person.
Okay.
Oh, category
Okay, I guess
zero.
because he's using mobile net too. All right. So that's the model. That's probably the default model inside the camera. The real interesting thing would be if he could have trained the camera. I don't know much about this one yet. But,
Yeah, I thought that was sort of interesting for
Yeah.
a Halloween thing.
yeah, but that model, that's the one that has 70 different objects that it can recognize, and one of them's a person. So, yeah. Cool.
The nice cones.
Nope, cone's not in it.
9 of the 70.
No. Banana is.
Would it detect a person dressed up as a banana or a person?
I would say a banana, but I don't know. Depends
What
on.
does a Tesla detect it as?
Yeah.
So does it say what this new camera costs?
$70.
No,
Okay, not too pricey then.
Yeah, it's getting complicated with that Raspberry Pi. They came out with a Raspberry Pi AI kit, which uses a PCI whatever interface, and it's got the same. It's an actual module. I mean, if you knew how to get that module by itself, you wouldn't have to buy, I think, the kit, and I believe it's more powerful than this. This is Sony just put some additional AI power inside of the camera. So I don't think this is as powerful as the AI kit yet. How does it say anywhere where I want to say this is not super powerful? It's like 1 MIP or something like that. I'm not sure.
Doesn't really have space, but he does have a play, so I don't know if you want to see the play part or not.
Yeah, go ahead. I want to see the play part.
Raspberry Pi and Sony have released a new camera that can efficiently perform real-time AI computations. People often fear AI because they believe it will steal their jobs. But this time I will create a new kind of fear. And this is the spooky season. I will use this camera to actually scare someone. I bought this Reaper, but it activates with a button. A button, Carl. Have the engineers thought that someone would press it and say, "Please scare me"? Luckily, I know how to fix that. I removed the button from the Reaper and replace it with a relay, which will be connected to an ESP32 that is linked to a Wi-Fi network. I'll hang the Reaper near the sidewalk. Additionally, I'll set up a hidden AI camera and a Raspberry Pi. The camera will detect people passing by and send a UDP broadcast message to all devices on the network. When the ESP32 receives the message, it will activate the Reaper, giving people a good scare. I will start with the most complex part, the AI camera. I'm using a Raspberry Pi with a standard Debian bookworm system and some predefined Wi-Fi settings in PiImager.
What that
Next,
means, you have
I'm
to use a
preparing the Raspberry
Pi
Pi by plugging in a flash card
How long
and
is
a
this
Sony
video?
camera.
About 7 minutes. Yes, we're running super well.
You can probably post it, a link, and we can watch it offline.
Yeah.
Okay.
It's a lot of work to go through when you can just get a PIR sensor
Yeah.
for $1.
Yeah, but
And it's probably, which would probably be more robust against Halloween costumes.
Yeah. Yeah. Are you saying you just buy a motion sensor and then screw in something?
Uh-huh.
There you go.
that's probably it.
Where Kareem is your,
Where's my Halloween spirit?
yeah.
Where's your
My-
Ruth Goldberg
My
Halloween spirit?
Rube Goldberg spirit. Yeah.
Ruth Goldberg,
Well, I don't know if it's showing you that anything now, but I have one other one I can show you. So that's not that. So I don't know if you're seeing what. So let me see if I need to probably do another.
I wonder if Sony just borrowed what's inside the MaxiCam and, repackaged it or something. Wow.
Yeah. Who knows?
Okay.
I think that's below
I
their.
don't think it's as powerful as a MaxiCam. I don't think.
Okay.
Yeah. It's definitely not as flexible from what I've seen so far. But it's just come out and there's
So
still.
are you seeing something right now? Because I have another little tab. I don't know if it's showing this one.
No.
No, not saying.
Yeah, I may just go with the other route. Do the whole screen. Okay, window, entire screen. Share. And then, okay, so just see that now.
Okay.
So this one's sort of interesting. It's a little spider type robot thing. I don't know if you're seeing the picture.
Mm-hmm.
Like basically, it's a little cam that opens up, and it doesn't look like all that many parts for it. So they one might put in the build project type things. Now how well it walks and that I don't know, but it does look cute in my mind. So that was the main thing for it, was the design.
Yeah. John, can you go through the 3D parts? Let's just click the left arrow, right arrow, I'm sorry. Okay.
So there's that. There's the real bridge light thing. That's why I said there are not very many parts to it. And it's sort of interesting because of that fact that, there's not many parts and, this interesting layout.
It's like maybe 2 servos per leg.
Yeah, because you have the one basically here, and then there's that one. So one that basically goes up and down, and one that goes back and forth there. So that was the other one was just for the OWL Raspberry, and this one's for design. That's why I saw this one. So those are the two things I sort of ran across that looked interesting.
I had Pat another question I wanted to ask you. Do you have
Go ahead.
Do you have an extra motor?
I have. Do I have an extra motor? I'm not sure if I have an extra encoder motor. I do have an extra non-encoder motor.
But it's similar. I mean, I'm just curious if you turned on with your motor shut down and you started another motor nearby, does the compass go nuts?
That's a good question. Easy enough to hook up another motor and even direct to the 12 volts. And
no, one that's not tied into the robot circuitry.
Right. just the independent motor, and just see, like,
Purely magnetic effects.
yeah,
So like just tie it into a battery and see if it
Hmm.
yeah.
if it'll make any problems. There's an idea.
I mean, if that does, I think you're screwed.
Yeah.
Unless you build a bigger shield around the thing.
Yeah, you're gonna have to figure out how to do some shielding if that's it.
I think I'm going to take up knitting.
What? Yeah. I don't know.
The only other thing I could think of that it could be is you have some sort of weird loop where are your motors like vibrating or twitching back and forth or giving multiple.
Oh yeah, with the compass going nuts, my navigation routine looks at the compass, and mind you, my compass is dampened down a little bit, but it still looks at the compass, which is swinging wildly, and trying to readjust my motors to go to a new heading steadily.
Yeah.
So I got motors that are having a seizure basically.
Yeah.
Hmm. Yeah.
And you can see where, hey, you point the robot in the right direction, and it gets going, and you hit the button on the remote control for the automatic mode, and it starts to go in that direction, and then starts to swing wildly.
Yeah. You might have to just take a reading and then use your other sensors to go for a while and then stop and check it out.
That's what I was planning to do with the odometry.
Yeah.
Is basically have it go basically in that direction
Yeah.
for so long. And I was doing a test with a 10-second interval where I go 10 seconds and stop for 2.5 seconds, and just before I start, I get a compass reading.
Yeah.
And then start going again.
Mm-hmm. You do have a GPS, right?
I do have a GPS, so
Yeah.
I do have that. I do have that heading is being pulled out into my routine. So
Yeah.
I think I'm going to try to say if I've got the heading to pull it down and use it.
Yeah. Okay.
If it's because when it's stopped, it's 0.
Yeah.
It's always giving me a 0.
Yeah. Well, what you want to do is, like I say, if you're using the current waypoint, the current location, and the X-1 location, you can get a direction out of it that way.
Yeah.
And that's all it's doing, I think. So I just
if they're not equal. So if I can put a past history and do an X-10 or something,
yeah.
and look at the 10 last values on my GPS, they're not the same. Calculate a heading.
Yeah. Yeah. Well, it's interesting. I know that at least in 1 year, David used his magnetometer only in the beginning. So he probably had the motors turned off or at 0 speed. And I don't know what he does now, so I'm not trying to say that he does it now, but I know at one year he used the magnetometer only in the very beginning of it. And then once he got
To figure out where the robot was.
what direction it was pointed in. And once he had that, then he never did it again he might have done it after he touched the cone. I don't know. But
so that's why I'm thinking about using a gyro and odometry.
Yeah.
So use the gyro to help correct the odometry when there's an issue.
Mm-hmm.
And basically try to use odometry to tell me where I'm sitting, where I'm facing.
Mm-hmm. Okay. Cool.
So is the gyro affected by the motors at all, by magnetism or anything? I don't think so.
Well, I guess it depends if your IMU is impacted. Although I'm sure if you had bad power or something, it would be impacted. If you have bad another problem you could potentially have is bad I-square C bus, because then, you know, something will get locked up.
Yeah, and that's my next worry about is
Yeah.
what's happening with the gyro.
Yeah.
And when you look at the gyro, they're incredibly small numbers, floating point. And they're always moving.
If you're using the BNO 055 and the what is it? IMU mode, okay.
Yeah.
You get a fused value. It just gives you, you're not doing an integration. You're not, you know, taking a gazillion readings and then trying to figure out the direction. What you're doing is you're just getting a direction whenever you get a reading. That's the way to go. It's already confused for you. So,
Getting a direction or getting a
well, an angle.
an angled
It's based.
angled
It's
change.
a relative angle, though. It's based off of wherever you started. So when you turn it on, straight ahead is 0.
Yeah,
Okay.
that's the problem I found with the BNO was that north was wherever it was pointed.
Right. Well, that's right. That's the way it's supposed to work. And
It's not north. It's just
It's-
0 relative.
0 relative. So what you can do then is you can, if you've got a true bearing, you can just change your 0 value to that true bearing, and that's all you need. And then after that, everything is based off of that value. Okay.
I will
Yeah.
say that with the BNO 55, if it receives hard shocks, it can shift the IMU mode a bit.
Yeah.
Right, more than just normal drift.
Yeah.
Like if you hit something hard.
Yeah.
Here's something for the truly. I don't think we'll do it this year, but I'd love to see some experiments next year. Is with I think it's called the M4G mode. That's where they substitute, instead of doing accelerometers and gyros to get your heading, they're doing accelerometers and magnetometers. And supposedly the advantage of that, assuming your magnetometer works, is you don't have any drift. That would be really cool if it works, but I don't know. And I never even contemplated doing that because, like I say, I haven't had good luck with magnetometers either. Though I'm going to try again this year, so we're going to see how it goes.
Well, if you have magnetometers working, then you can just put it in its full fusion mode, and the whole purpose of that is to run mostly off of the gyros for the heading, but correct the heading occasionally by the magnetometers. But your magnetometers have to be, calibrated and not being upset by magnetic disturbances and electrical wires nearby, and wire or rebar running under your surface, that kind of stuff.
Yeah. Another thing, Pat, well, no, that won't have to do it. But I got to admit, Ray's saying that he's having luck in 9 degrees of freedom would be cool. But I'm actually thinking of just using the BNO 55 because I have it in 6 degree, in
IMU mode, it works great.
That's
I
what
love
I'm
it.
doing.
That's what I always use. It works.
And then I'm going to have I got a separate magnetometer that's part of one of my GPSs.
So you put the magnetometer up in a helium balloon, and that'll get you the distance needed to get it outside of all of the interference.
Yeah. So, I mean, I don't know. It'd be cool to see. I'd like to hear how the independent motor, just using it like a sensitivity thing, like if I start the motor across the room, do I have problems? If I put it underneath the robot, do I have problems? it would be kind of interesting to just see, you know, if I hold it 6 inches from the magnetometer, does it go nuts? You know, 12 inches, you know, just try to find roughly where it is. Yeah.
Yeah, well, I'm 3 feet above my motors.
Yeah, I know.
And-
That's why I'm saying I'm really having a little trouble kind of like seeing why this would
It
happen.
almost has to be coming up through the wires.
Yeah, that's what I'm thinking. Yeah. So that's, like I say, that's probably the other option is, you know, you just take a battery and put it up there. You know, just a battery with so that it's independently powered. Then the only thing you have left is the I²C, and you see how that works. Yeah.
Well, I like the motor idea because I do have a motor, like I say, without the encoder, but I have a motor that I can just power up off a battery, 12-volt battery,
Yeah.
and see what's happening. So while the rest of the electronics is powered up,
Yeah.
power it up from separate 12 volts and see what's happening.
Yeah, it'd be cool if you know, like I say, you just maybe just hold it in the air, you know, 5 feet away, and then go underneath the robot because that's where your other motors are, right? And
Yeah.
see if all of a sudden it just goes nuts.
So the other thing I could do is power my motor driver with a separate 12-volt power supply. Then I'm powering the robot and check the same thing.
That definitely, you know, you probably I'm thinking on your sensor suite, they should probably be completely independent from any other stuff, you know?
Yeah, so
like
that's,
motor drivers.
but most people don't put 2 separate batteries on their robot.
No, but well, I want to say you look at Mike's indoor robot, he had four buck sensors sitting right next to each other, each one powering something different.
Yeah,
And-
well, that's I do have another power supply, a buck converter, and I could add a separate buck converter in there for some of the sensors.
Yeah. Okay.
So I've got one powering up the Raspberry Pi and powering up a USB hub.
Yeah. I actually, you know, did 3. On my last one, I had 3 or 4. This one I'm trying to cut down because I'm using these boards, but that's a different story. Let me show you something.
Well, he's out of the room. I'll just ask if any of you folks in Texas have heard of the Long Now cloud clock installation out in West Texas. No? I heard about it this weekend by a guy in Canada who did it. This thing is apparently in this monstrous underground cavern, and it's intended to keep perfectly accurate time
10,000 year one.
the next 10,000 years.
Yeah.
The Long Now clock.
Oh well, I can't find it, but I had an easy way to add buck converters to a battery line. That's an in-series. I take whatever connector you're using. I use an XT60, and I put them right next to each other and solder this piece of house wiring. You know, usually solid bus number 16 between the two of them, and then I solder onto that whatever the leads that are going to eventually power the buck converter.
Okay.
So you that way, and then take a piece of heat shrink and just cover up the whole mess. And that way you can have 2 or 3 feeds coming off of your battery without a whole lot of wiring complexity.
I've been using a Wago connector.
That works.
That'll do it.
That'll do it too.
So,
Yeah.
A lot easier.
Yeah.
yeah, I'm using a Wago connector, so But I can beef up some of my wiring. It is 16 gauge for the most part. I use, I think 14 gauge going to feed my motor driver. But I could beef it up a little bit everywhere as well for line loss. But those Wago connectors I found are nice for splicing a line and splitting it off. Incidentally, they are not CSA approved in Canada. You can't use them.
Wagos?
No UL. Yeah, Wagos. So in about 10 years, they'll allow them in Canada.
Wow. So they don't allow UIL. What is it? UL?
Yeah, CUL.
They
So
don't.
there's a Canadian version. There's a Canadian version of UL, CUL, and
They're better, are they?
They're not on the list. So it's interesting that the U.S., like the electrical code, in the U.S. has followed the IEEE amperage tables for decades, and probably in the last 10 years, they finally switched over the Canadian electrical code to more closely follow the IEC tables. So, but they, yeah,
Not
so
completely.
not completely. So they've specifically disallowed it in residential areas. So where in the US you can run some 20 amps on number 14 wire, in Canada you can't, only 15 amps.
Well, down here, caveat emptor.
My Italian's a little rusty. So is my
Buyer beware.
yeah.
Full on capitalism.
Oh yeah, exactly. So it's been pressure that's I believe is switching wire tables in Canada, because you buy equipment made elsewhere, Europe, US, whatever, and it comes across and they're saying, well, you can't run 20 amps on that short chunk of number 14. And so they're slowly switching things over.
Well, the wires, they act as heaters, so in the wintertime, your walls are a little
And
bit.
you need that up there, right?
We need it to supplement the heat pumps, which aren't going to work very well.
Yeah, they've got heat pumps for cold weather now, apparently all the way down to 0 Celsius.
Yeah, it's amazing what they're doing with that.
Put one in your house here, you'll freeze to death in the winter.
Well, I have a ground source heat pump, so it's like
There.
70 degrees year round.
Those are working well here, the ground source.
Yep. I think there's an upfront cost. Hopefully it's super efficient. Hopefully it pays for itself. I don't know how long the unit's going to last, but
yeah, but you don't have a lot of heating to do where you are.
it'll late January. Well, we certainly don't get as cold as Canada, but
Nowhere near. I mean, a few years ago we had that cold snap that Ted Cruz is still trying to
we're 240
worry about. Yeah.
people died or something.
And there wasn't electricity.
What's that?
No electricity.
No electricity. Yeah,
Your cold
the heat pump sort of becomes
snap,
useless.
Yeah, your cold snap
That's
is
true.
where we decided to take our sandals off. I'm trying to remember. It was David Anderson that asked me, how do we get away from water pipes freezing in our walls when we're up north here? And I said, it's quite simple. We run them through the floor. We don't put them in the outside wall where they're going to freeze.
Keep them out of the walls. Don't put them there.
Yeah. Is there anyone else that's got something robot related?
I can chat a little bit about the conference I was at this weekend. This is here in Hamilton. There's a center of excellence, a provincial center of excellence, that started about 20 years ago. And it represents the crossover between medicine and robotics. It's called the Center for Minimally Invasive Surgery. It started out originally dealing with the interesting subject of telesurgery, being able to do surgery at a distance. And the particular guy who runs the center here was a pioneer in that field. Did a lot of work with NASA originally and still does. So about 15 years ago, he started a series of conferences as he realized that educating people in what he was doing, especially the fact that robotics were critically important to medicine, because no one had ever thought of that before. And we were fortunate to get invited to the first of his conferences and have been to just about all of them, I think. So this year's was this weekend. About half of the lectures were on medical topics, and the other half were on robotics and artificial intelligence. Essentially, what he's been doing in his Center of Excellence is moving from telerobotics into automated surgery. And automated surgery now is a product. If you go and look at, for example, Stryker's product catalog, you will see automated surgical equipment for sale now because it was developed here. And they now have an advanced prototype that they're beginning clinical trials on in autonomous surgery. This stuff is incredibly sophisticated technology. It's pretty serious medicine as well. But they've now begun clinical trials on completely autonomous surgery. Think Star Trek. This stuff is amazing. He did a little talk on it on Sunday. But half of the presentations were in automation fields and robotics fields. For instance, one of the chief engineers at MDA Space, who originally started out in Toronto, talked a little bit about the way they do development and training these days. In particular, he talked about their latest new headquarters building that they're currently building and what's called the Dreamer Laboratory. Think in terms of a high school gym-sized structure with computer-controlled precision gantries in the ceiling to provide zero gravity capability and a large number of high-precision multi-axis robotic arms, which are used to carry the already manufactured physical components of the equipment that MDA makes. MDA is known mostly for the Canadarm, but they've also done a whole lot of other things in the space and aerospace field. What they've done is they've mixed virtual reality along with the physical testing they do in this facility to develop advanced control systems. And their designers now spend as much time in virtual reality working together with the physical equipment and the virtual equivalent in order to make this stuff work together properly. He showed some videos of some of the stuff that they're developing, which I tried to find earlier today to show you a little bit of, but none of that stuff's in the public domain yet. But I was if I was a young engineer today, by God, I would love to work at that company. The stuff they're doing is mind-blowing. So there's some fascinating stuff coming out of the kind of mixed virtual reality immersive environments these guys are doing, not only for test and development, but also for training. And the other point he made is that something that most people don't know about, 90 to 95% of all of the Canadarm work that's done on the International Space Station today is ground-based. It's not done up on the space station. It's done from remote control centers located either in Houston or in Montreal. They plan everything very carefully, but they do most of the work, some of it manual, most of it in semi-automatic mode, but all controlled from the ground. Now, what that's done is that's gotten MDA some very substantial development contracts to prepare for the Moon Gateway satellite system and for some of the initial thinking of colonization of the moon, because it's believed that there will be some pretty dramatic developments that will need to take place in equipment that runs in zero gravity or near zero gravity. And they have this state-of-the-art massive development targeted exactly at doing those kinds of things. I had no
So
idea.
you're telling us that so you're telling us that even astronauts are susceptible to AI displacement.
And automation, yes. Well, part of it gets even more fun. One of the other speakers was a guy, Dr. Greg Biden, who runs a company located in Northern Ontario called Penguin Automotive Systems, Automotive Research, or Automation Research. It's a spin-off of Inco Metals. This guy started out as a mining engineer 40 years ago, developed the first tele-robotic mining systems that allowed operators to control up to 10 semi-automatic mining machines 5 or 8 or 10,000 feet below the ground from a central control room on the surface. And he developed a lot of those systems for Inco, who then marketed it to other mining companies. He then ran the startup company to further develop these mining automation systems. He's now a standalone company, and he only solves specialized automatic mining problems around the world. He doesn't do mundane stuff anymore. One of the specialized areas that he now is working in is for NASA, who has asked him to develop the detailed project planning for the mining that will have to take place deep underground on the moon to develop a moon colony, and then to develop the mining operations that will take place on the moon in order to make it profitable. So he's now working at developing that stuff. And he says most of it will have to be controlled from Earth because there won't be enough astronauts to do anything up there. They're going to make it as autonomous as they can, but the intention is that they will control most of it from the Earth. Now, that's a really interesting control problem. So he talked for quite a while about that. He mentioned, I asked earlier about the long time moon clock. What did I call it? The long now clock in Texas, because this particular guy did the original design work for the cavern and the mining equipment that was used to create the cavern that long now clock has been built in. Anyway, fascinating conversations around automation. The president of Space Canada talked for a while about the Canadian orientation on space business, more business than technology. But a little known company called Mission Control, which I had never heard of before, based out of Ottawa, develops, they started out developing or doing software development work for embedded real-time control systems. That morphed into artificial intelligence, which morphed into the interesting problem of how to gather and process enough information to build artificial intelligence-based navigation systems for use on the moon, where they don't have enough information to do the deep learning and machine learning required ahead of time. So they have contracts to develop systems that will go to the moon, acquire a lot of data, process that data from a deep learning point of view, process it from a machine learning point of view to create navigation and guidance systems for use on the moon, and to do it in scarce computing resources because they won't have the bandwidth to communicate all this stuff back to Earth and back up to the moon again. Just a small venture capital based startup. They have about 30 or 40 people now, but all developing what I think of as distant artificial intelligence development systems. The amazing stuff they talked about.
How did they solve the moon time issue? Like the moon is a different time system than Earth.
That never came up. Issues that came up in conversation were things like, how do you keep mining equipment, or for that matter, electronic control equipment, working in the temperature extremes that are expected in the very rough mining environment of the moon, where you can run between minus 200 degrees and plus 150 degrees in the course of one lunar cycle. Really interesting problems. So yeah, this is one of those conferences I love to go to because you get exposed to so many things that you normally never hear about, especially this crossover between medical systems and robotic systems. So fascinating.
Well, the Terminator series has taught us a few things about maximally invasive surgery.
Yeah. Well, what Dr. Anvari showed some of the development videos that they're using as they work towards this completely automatic, completely autonomous surgical suite. And it's just mind-blowing to watch this thing. He says they're now into clinical studies. That's pretty advanced thinking. It only goes after one kind of medical problem right now, but they are already started work on 2 more.
I guess you can isolate yourself from surgeons with delirium tremens.
This research center gets a lot of support from NASA, of course, and interestingly enough, the U.S. military is a huge supporter of this research center as well, because the military, of course, has significant issues in the battlefield associated with medical aid requirements. So they're very interested in the outcome of a lot of these things. And naturally, the major commercial operations have jumped on board. I mentioned Stryker. Stryker is probably the biggest surgical equipment manufacturer in the world. So they're on board as well. They also hold a student robotics competition as part of this conference. So they had 8 teams showing their various projects, some of which are basically high school or undergraduate university level, and a couple of which have already moved into the business incubator stage. Things like automated hand systems, which are classed as very low cost to replace traditional prosthetics, which are very expensive. One kid is building an autonomous robot whose purpose is to go out and pick up litter. He says, people don't take litter to the garbage can. He says, we have to go out and get the litter. So he's working on developing a robot that can identify and collect litter. It's an amazing project.
Gonna put the road gangs out of work.
Well, that wouldn't be a bad thing, but he's still got a long ways to go. But it was a lot of fun talking to him. He's also very, very smart for a high school kid. He's already won honors at both the Canada-wide Science Fair and the International Science and Engineering Fair in the last 2 years. Pretty bright kid.
He should just market it to our local coffee shop establishment in Canada. And, their cups are everywhere.
I can think of a whole new job, and that's the guy who waits outside the door to say, give me your cup and I'll put it in the garbage for you. Yeah, litter from the big 3, right?
Exactly, yeah.
Tim Hortons, McDonald's, and Burger King.
I didn't want to mention any names.
Oh, well. Anyway, that was it. It was a fascinating conference. We enjoy going every year.
That was interesting.
And it's free, paid for by our government.
Harold, you're pretty quiet tonight. You joined late. Do you have anything to present?
No, I'm actually driving home from the makerspace, the lab, and just listening, going on about stuff. Things, not really anything major to present. I know. Imagine that. Me not having nothing to say. Go on. Something's wrong.
I thought you'd have another TAC attack update for us, but if you're driving, I can understand why.
Yeah, I am driving, so I'm going back on mute.
Yeah. Well, my update is,
You have
this is
anything?
Mike, is the theater group put a really important rehearsal on that day, on Robo Columbus Day.
Oh,
So I can't
really?
even come out and drive my car. Oh,
I got a
that's not
conflict too.
good. Oh no.
I got a tournament that day.
I guess the young minds are more important than the old ones.
Yeah, they are. Quite honestly.
Yep.
Me included.
They're the ones building the surgical equipment that'll keep us alive.
Mm-hmm.
So on the theater one, did they ever come up with a design that works, or you change up the design, or how is that design going, Mike?
You're muted, Mike.
Mike, your robot, is it all going well for the theater?
Oh yeah. It's doing well. Just in a box right now, waiting for a rehearsal. So
So you've tested it in a crowd and everything, and it seems to be working well?
no,
No.
we'll have crowds during rehearsal. Okay.
That's what rehearsal's for.
Yes, but will they have people at the rehearsal enough, or will it be a surprise?
Yeah, still got to find some drivers for it, but I'm thinking that I think I'd prefer to hire theater students because they don't need to know how to build the darn thing. They just need to know how to run it, which, teenagers know how to run stuff like that. And the theaters can give the puppets like emotions that an engineering student probably couldn't do as well.
Okay, well, thanks.
Mhm.
Is there anyone else that has an update or a topic to bring up?
I think I'm ready to sign off, guys.
Yeah.
Uh-huh.
Only thing I wonder about is Doug coming back, or was he going to live for something? Do we know about Doug?
I don't know. I guess he's going to have to present next time unless he comes back.
He had a call he had to take, looked like.
Yeah.
Okay.
He grabbed the phone and disappeared.
All right. Well, good night.
Okay, guys.
Good night,
Have a
folks.
good
Night,
night.
y'all.
Thank you.
Bye.
Hey, take care.